Hello, hello. It is Monday, May the 11th. We have less than a month left in school since we get out June, 7th or whatever. So we just have a few more weeks to go. We are finishing up chapter 7 this week. We will start chapter 9 or 10. I haven't decided whether we'll do coordinate geometry or we'll do circles. We'll probably do coordinate geometry, a little bit of that, a little bit of circles, and maybe a little bit of volume, get a little bit of all the remaining chapters except for the last one. Today we are finishing up chapter section 7.4, right triangle similarity. Last Friday we talked about geometric means, which was a part of this right triangle similarity. We also solved a right triangle that was divided by the creating an altitude. And today we're just finishing up. So today we will talk more on altitude and sketching similarity triangles, which is very short. We'll do some problems and then you'll have classwork. You'll have a handout, which you should kind of refer to as we go over this handout, as we go through the lecture. So review geometric means. This is just from Friday. Basically, we looked at it. The definition is a positive square root of product of two numbers. And then basically we're back looking at ratios. And again, this is a handout from Friday to show you that when you have that altitude that's drawn from the vertex of the right angle of the right triangle and drawn to the hypotenuse, and it doesn't split the hypotenuse into two even pieces, but what it does do is create two other triangles, one smaller than the other, and both are smaller than the original one, of course. So problem number 2 from May 8th, which was Friday, we basically looked at how can we create or solve for the value of one of the, in this case, one of the legs of the right triangle, in which case they already gave us the altitude. And so basically we take the short leg of triangle ABD and the long leg of triangle ABD on one side of the equation, and then we equate that with the short leg of the larger of the two triangles, of triangle ATN, with the long leg of that triangle ATN, which is labeled X. We then cross multiply and divide by 5, and we get that the length of the longest leg is 10 or 20, excuse me, from the split of the altitude. So if we look at this triangle, this is problem number 5 from the handout, from today's handout, not Friday's. And I brought the template back from Friday and also earlier in the presentation. Let's look at what AT is in our example from problem number 5. AT is the altitude of the, which splits the triangle into two pieces. And AT in this case, we will say is reference to the smaller triangle and it's the long leg of the smaller triangle. Therefore, TS is the short leg of the smaller triangle. We'll put that in the numerator. So now we've completed the left side. But because we know AT is the altitude of the triangle, therefore AT must go in the numerator or the opposite position that it went on in the left side of the triangle. So we have AT and TC is the long leg of the big triangle. And so we have to use that because AT is the long leg of the small triangle. So we have to have long leg, short leg, short leg. So this is the answer to number 5. It's just recognizing, do you know how to split up the parts of the triangle? So in the next problem, 14, I'm going to do this one because a lot of times it looks the most difficult, the last problem of the chapter. So by doing 14, you notice there are 3 variables you have to find. X is the altitude of the large triangle. Y is the length of the smaller, is the hypotenuse of the smaller triangle. And Z is the hypotenuse of the second largest triangle. within points GH. When we look at this, we're going to just follow the flow and start off with trying to find X. And we're going to use the technique in this chapter, and which is the geometric mean, because we're looking for X, which is the altitude. So we're going to use the geometric mean process. And we have a 6 and an 8. So we're going to use the little triangle against the second largest triangle. The 6 is the short leg of the small triangle. The 8 is the long leg of the bigger triangle. X is the short leg of the big triangle, but it's the long leg of the small triangle. So I set up my ratio x over 8 equals 6 over x. I cross multiply, I get x squared equals 48. I square root, and I get the square root of 48. Since it's not a perfect square, I'm going to just leave the square root there. And again, forgive me for not having a square root symbol to put on that 48. For the next two, I'm going to find z first, then y. Just you can find y first or z. I just decided to mix it up. And I'm going to do it on a separate slide so that it's easier to see how to pull these triangles out. So now we're going to solve for z. And since we're solving for z, I'm only looking at triangle HFG, which is the second largest triangle. I know that the altitude is the square root of 48. We just figured that out. And we know the long leg is 8. And we also know that triangle HFG is a right angle, which means we can use the Pythagorean theorem. So when I do that, I get the square root of 48 squared plus 8 squared equals z squared. Whenever we square the square root, we just pull out whatever's inside the square root. In this case, is 48 plus 64, because 8 times 8 is 64, and we get 112. And so therefore, z squared is 112. We have to take the square root of that. So now we're left with the next slide, which is look for y. And again, you could have found y first instead of z. I just did that just so that we can see what's going on. In the top right corner is what we found so far. And what the diagram, the second diagram is a breakout of the small triangle. This time we still know that the altitude is square root of 48. But this time, since we're looking at the smaller triangle, we're going to do the Pythagorean theorem again. And we're going to find square root of 48 squared plus 6 squared equals y squared. And we end up with 48 plus 36 equals 84. And therefore, our answer is the square root of 84. So now, as you can see, just do a piece at a time. This one triangle, once you draw the altitude, gives you 3 triangles, which are all right triangles. And you can just use the theory of the Pythagorean theorem if you're looking for a leg of a right triangle. So today's homework from the handout is 6 through 14. We already did 14. Hopefully that helps you understand how to do the rest of the problems. If not, please don't hesitate to call me, or rather email me, not call me, and set up an appointment so that we can meet and do this together. Have a nice week. Thank you. Bye.